Many targets in the night sky are huge. What if your target is too big for your telescope? This video will show a possible solution to that. After this video, I hope you have gained some insights into processing mosaics using free software. I am Martin Schoenmaker and I call myself Koplamp on this channel. If you are a regular visitor, thanks for sticking around. If you're a new visitor, welcome. On this channel I intend to show how I stumble my way through this wonderful hobby of astrophotography. You'll primarily see me use free tools like Siril, Photoshop being the exception, although I really should invest some time into learning GIMP. Let me first explain what this video will not show. We're not going over how to set up your telescope to shoot the mosaic. I think there are many more people who are much better presenters into this material than I am. But if you are insisting on me presenting something like this, please leave a comment below and perhaps I might do that after all. What is a mosaic, you ask? Well, basically, it is a set of individually processed images that are just stitched to one another. So it ends up showing a bigger portion of the sky than a single image would. There are many free pieces of software that you can use, and my tool of preference is Microsoft ICE, the image compositing editor. So you've shot data. Perhaps even on multiple nights like I did. Well, now you need to process them individually because those images, those stacks, will form the panels or panes of the resulting mosaic. I got a bit over ambitious and I got 24 of those stacks that will be shown at the end of this video. Processing that data can become a bit tedious as there are a lot of repetitive tasks. Siril and the scripting engine of Siril can come to the rescue, but there's a tool called Cyrillic that will make it even easier. Instead of manually pre-processing all the images, you can just do it in one go with Cyrillic. Setting it up in Cyrillic needs a few prerequisites. If you don't already have Cyrillic, you can find it on gitlab.com. You can just find the version for you by looking on the website that I linked in the description below. When you run the program, you'll need to tell it where to store its data. Similarly as with Siril, it needs a home directory. You can find the home directory by going into the File menu, then go to Preferences, and then the work directory can be defined. And you'll also need to point out where Siril is installed. This is different for everybody. In my case, I run the developer version, so it's in this folder as shown on the screen now. I would also highly suggest, if you are running on Windows and you have Windows in the developer mode, to set Cyrillic to use symbolic links. This will reduce the hard drive usage very much because it doesn't actually copy files, it just makes links to the files. Cleaning the object directory before launching the script, that's also advisable because every time you start it over again, all those files, because it's not only linked files, there will also be files generated like stacks and stuff that will of course use up hard drive space. So whenever you fiddle with settings and want to start over again, having the first option checked means that it cleans the directory for you. Return to the work directory at the script end. Well, that's okay. You can also set it to run Siril immediately, but in my case I don't want that because this is just basically a mosaic preparation that I'm doing. So it's not only one file that this results in, but it will be many files. This I can uncheck. I don't want a TIFF format file as well. I do want it to work in 32 bits mode. The fits compression I will leave off. Sequence mode, I think this is the default, so I will leave it at that. I have the developer version of Siril, so I've checked this, otherwise the script will fail. Similarly, if the script fails and you have this checked, then you probably do not have the development version of Siril, so then you have to uncheck this. So if you get a message upon starting the script that the version is not matching, then this is the case. And the CPU and memory settings I will just leave at 0, which then is the default setting. So this mosaic thing that we are doing now, it will mean that we're running a multi-session script, but for all the sessions I have identical parameters. If we go into the website of Siril, it shows it as well when I go into the, was it the documents? Yeah, this one. So multi-session needs to be checked because I will group the resulting file, and that means as well that I have stacks for every session. So I will have a stacked file for every panel of the mosaic. Next thing what we need to do is we need to tell Siril where to find the files. Let's start off with the first one. So we're going to do the Veil Nebula in this case. It's mono data, as I was using my ASI 2600 Pro, and I also checked the H-alpha. Actually, I don't think it makes any difference for me which option to check, as I have only shot H-alpha, but should you for instance use Cyrillic to combine H-alpha with red, green and blue, or perhaps an SHO palette, then you can use this option to distinguish the lights from the other ones. So we've added the light, but now we need to add the files as well. So I will start with my biases. I will apply some shortcuts into my processing, as I am using the ASI 2600 and I am not using the proper calibration files. I can show that with the synthetic biases page. So this is what you get if you only subtract the darks. This is what you get if you only apply a flat. You will get those vignetting effects inverted actually. If you also apply the offset but only on the flats, you still don't get rid of the vignetting until you use the offset both on the lights as on the flats. So this is what we are going to do. If you want to do it properly, you will of course need to apply darks. Then the darks will be subtracted from the lights, and the offset, the biases, will be subtracted from the flats, and the result of that is used in the division with the calibrated lights. We're going with this. This is my shortcut. Okay, enough for the theory. Let's add the biases. So I only have a master bias that I will add. Cyrillic will know that this is a single file and such a master file. So this is my master flat. Okay, I have flats, I have master bias. I will add the lights later, as I have found that when I use it like this, with the biases and the flats already set up, when I then add a new set of lights, a new session to Cyrillic, it will already copy over the biases and the flat settings. So that's nice, and I'm going to misuse that property. So this will be Veil 2. See, there we have the biases. I have a 6-panel mosaic to prepare. So this is 3, 4, 5, and last one 6. We'll start with the first one. I'm going to add my lights to it. So here are my 6 panels. So these ones I can select. Then I'll go to the next one. Just drag and drop my fit files in the proper box here. So number 3, this one. drag and drop. Number 4. I got a little less data there. Number 5. And last but not least, number 6. Okay, so now I have files in all the panels. That is also represented here. So we can see that each of those panels has now files in it and an offset and a flat file. If we look at the process, then Cyrillic will show us what the preparation will be. So it shows now that the images are loaded. It will apply the flats, it does some cosmetic stuff, registering and stacking of the files in that specific set. So we don't see the master biases applied yet. So that means that we need to change some settings still. So in the Properties tab, we can see that Preprocessing will need to subtract the biases. Check that tick box, and as we have set the identical parameters for all layers, this will apply to all the layers. You can see it's checked now for all 6 of the panels. If I go back to Process, it now subtracts the bias from the lights, and it then will divide it by the flat. You might notice that this flat is now not subtracting the master. That was here, so flats minus offset. But my master flat has been created using the offset files. It's correct, like so. What I also like to do is, in the process of stacking, it will do registering. When you don't have proper results, proper data in all of the images, for instance because a cloud passed by or other reasons, then selecting the file to register against might be problematic. And if that is the case, then I suggest to tick the to pass checkbox. What it then essentially does is it will go over all the files and then determine the file that has the best data and use that one, the best sub of the bunch, as the one to register the rest against. So having set up all this, we're done. We can go into Actions and we can click on Build Directories, and it will then link the images. So that is where it is important to set your Windows machine into developer mode to make sure that the symbolic links option is set. If you want to know how to set your Windows into developer mode, just open the start menu and start typing developer settings or developer, and you will end up with a setting that says that you can turn on developer mode. Okay, so Actions, Build Directories, and the program will start working. So the scripts have been generated. It's as simple as that. You can just click this button and it will start building the files. Here we go. Okay, so we're done. And now we need to load the files into Siril and do some basic processing on them so they are as similar to one another as possible, which will help the eventual stitching process. What I'm going to do is I'm going to simply drag the file over to the user interface of Siril, and I'm going to do a few steps on each of the files. First thing I'm going to do is, let me put it in auto stretch so we see what we have. First thing I'm going to do is I'm going to do a plate solve on the image, and I make sure that I have the flip image if needed checked. This will result into images that are rotated in the same way. So yes, you probably saw the image was flipped, and from this stage I will go and do a background extraction, and I'm going to click the add dither function so I will not have any weird banding patterns occurring, because I have had that happen a few times. I will leave the settings here as default. I can click generate and I'll click compute background. This I will apply, and the final touch I will have to do is I will do a auto stretch. So I can go into the histogram transformation window, click the auto stretch, have it applied, and then I will save it off as a TIFF file. And I'm going to save it. That is one image done. Let's go to the next one. And this I'll do for all the 6 files. And I think this is the most tedious part of the process. And I'm actually thinking of a possibility to script this, but I haven't yet found out how to do this. Okay, so now we have 6 TIFF files. Let's sort it by type. Here we have 6 TIFF files. We have the image composite editor installed already, and again I will leave a link in the description box how to get it. But once you've installed the image compositing editor, then you'll have the option to just select the TIFF files, press your right mouse button, and in Windows 11 you need to click show more options, and then you'll find stitch using image composite editor. You just simply click it, it will load the image composite editor. It will try to look for updates, but it isn't supported or maintained anymore. So, oh, wrong window. So this is how it now looks. And I can just simply click next. It will align the images. It will composite it into one image. And in just a few seconds it will be done. And there we are, and we have a mosaic. You could go ahead and crop the mosaic. You get the point. You can simply do a crop there. I'm not going to do a crop. I'm just going to save it, and I'll save it as a TIFF image. So this time it is, where did I put it? I'll put it in my Siril working directory, and I'll call it fail ha-stitch.tiff. That's a nice name. I think saving the file takes longer than stitching it. There we go. As you can see, it's nice. There's no stitching artifacts as far as I can see for now. And this is just the subs of one night, so it's not something that is really awesome or something. There could be more data added to it, and it will get more detailed with less noise. But I do think that this mosaicing proves to be very interesting. And to emphasize that a bit more, as I showed at the start of the presentation already, there is a big TIFF that I created, which has the entire, let's not load that big one because it's really huge. I think this one is big enough, and it has the Cygnus area from the Propeller Nebula all the way, Propeller Nebula over here, all the way to the Tulip. And to show the amount of detail, this is a 50% zoom on it. Where's the propeller? I need to scroll so much. Propeller is up here. This is called the propeller. I think a follow-up video should allow me to scroll around this image and to show some of the highlights of the area in the Cygnus region. Well, there you have it. Mosaics in a free and easy way, if I say so myself. If you have any questions or suggestions, feel free to leave them down below in the comment section. And while you're there, if you haven't already, please consider subscribing to this channel. You will then be notified by YouTube, of course, of me uploading new content. And I think my next video will be, as I mentioned, about the objects that are visible in that big mosaic of the region of Cygnus. I'm not sure when I will upload that video, because I still have to create it, and that takes quite some time, so yeah, be patient. Some other ideas that I have: I'm going on a holiday within a few weeks time, and I will probably take this mount, the AM5, with me as a substitute for a Star Adventurer. I don't own a Star Adventurer. I brought one that I could borrow from a friend last year, and it worked pretty nicely, but I want to use my AM5 this year with just a simple Canon camera on it. So I think I should create a video about that too. So thanks for watching. See you next time.